Spartans! Prepare for glory!
Step one, you say we need to talk. He walks, you say sit down, it's just a talk. Smiles politely back at you. You stare politely right on through some sort of paper to your right. She looks down when you look up between the lines of oh and fuck. You begin to wonder why you suck. Where did I go wrong? I bombed my test. I thought PVA was my very best. I would have stayed up and worked all night had I known I would fail the class. Distance and velocity, acceleration and the time. Failing it is such a crime. This paper just cannot be mine. Lay down a list of what went wrong. Forgot the statements and the sign and didn't draw a sign line. I didn't draw the sign line. Where did I go wrong? I derived it wrong. Should have used power rule all along. I would have stayed up and wrote a song had I known what is PVA. She begins to let me know the recovery will surely show. You just have to take it slow, or maybe it's that you just blow. You can do one of two things: ignore it all and let it ring, or get it right like you are the beast, 'cause you can get a 70 at the least. Where did I go wrong? I bombed my test. I thought PVA was my very best. I would have stayed up and worked all night had I known I would fail the class.
Let's get down to business so we can ace this test. Rate of change is the slope of the position function. It's the saddest grade I've ever seen, but you can bet before we're through, Mr. I'll get an A out of you. Finding critical points where velocity 0. I said it changed direction when it stayed at rest. Your spineless, pale, pathetic lot, and you haven't got a clue. Somehow I'll get an A out of you. Critical punch and short arrest, also change in direction. Boy was a fool in school for messing up. You don't even know what displacement is, how far you are from where you started, and distance is the total amount you've been. Speed is the positive of velocity, depends on that and acceleration. It increases when signs are the same, it decreases when signs are opposite. Time is racing toward us till the test arrives. Follow the study guide and you might survive. You're not suited for the PVA, so go pack up, go home, you're through. How can I get an A out of you? We can do it if we just try. I'll stay up studying all night long with all the smarts of a calculus nerd. We'll ace this test, it's the last thing that we do. We can do it if we just try. I'll stay up studying all night long with all the smarts of a calculus nerd. We'll ace this test, it's the last thing that we do. So for this problem, we're going to demonstrate some of the concepts of PVA. So Jimmy's moving along a horizontal line with velocity measured in feet per second given by the equation v of t equals e to the sine t minus 1 on the interval 0 is less than or equal to t is less than or equal to 6. So part A, in which direction is Jimmy moving at t equals 5? So for this problem, we already have the velocity function, so we just plug in 5 for t, so e to the sine of 5 minus 1, and use your calculator to get that equals negative 0.6166. Part B, when does Jimmy change direction? You can find this by creating a sine line. So you create the sine line, you put the two endpoints, 0 and 6, and pi is the critical value, which you find by setting the equation equal to 0, which I use the calculator for. So then you plug in a value between 0 and pi, and if it's positive, you write positive, so there you go. Then you plug in a number between pi and 6, and it was negative, so I write a negative sign. And we know that it changes direction Jimmy changes direction at t equals pi seconds because velocity changes signs. Part C, find acceleration at t equals 5. So the acceleration function will be the derivative of the velocity function. So I use the calculator, and just kind of like part A, you just plug in 5 for the acceleration equation, and I did it in the calculator to save time and got 0.109 feet per second squared. Seconds are squared because it's acceleration. D, is speed increasing or decreasing at t equals 5? Well, you know from the song that speed will be increasing when velocity and acceleration have the same sign, and decreasing when they have opposite signs. So from this, we know that at t equals 5, the velocity is negative, and at t equals 5, the acceleration is positive. So if one's negative and one's positive, the speed is decreasing because velocity is negative and acceleration is positive.
Remember, displacement is how far you are from where you started. So it is the integral from points A to B of vt dt, in which v of t is the velocity function. Distance is the total amount a particle has traveled overall. Therefore, it is the absolute value of the integral from points A to B of vt dt. And just as a quick recap, the derivative of the position function is the velocity function, and the derivative of the velocity function is the acceleration function. So s double prime of t is also the acceleration function. Likewise, in contrast, the integral of the acceleration function is the velocity function plus c, and the integral of the velocity function is the position function plus c.